the concept of the property of liquid. Okay, and property of liquid, I just want to tell you this property of liquid. Properties of liquid. What do you understand by the term property of liquid? You may search the study material. Okay, and this study will already explain the concept of property of property of solid, liquid, and gas. On the basis of the different terms we have discussed here, I just recall the concept here: rigidity, diffusion, space between the particles, and some other also. The property of liquid, you may see. Look at this, the property of liquid. Clear? And before that, I just want to tell you the property of solid, liquid, and gas. What are the characteristics and the aspects which we have to define for the solid and liquid and gas? First is mass. You may see this: mass, shape, volume, compressibility, fluidity, rigidity, diffusion, space between particles, intermolecular space, and the intermolecular force is also there. Okay. So, mass, if we will define on the basis of the solid, liquid, and gas. So, mass, solid has definite mass, you may see, and liquid is also having definite. Indefinite we can speak here, and definite is written here. You may correct it. The differentiation table is both mass, definite. No, sorry. All the three have the definite mass, because mass is the basic characteristics of the material. Okay. Shape, solid have definite, and liquid require the space of container. Gas, see, take the space of the container. Volume, definite, and indefinite. Compressibility, not possible, almost negligible. Means compressibility means you can press it like that. You might have seen the gas is filled into a fragrance bottle. The spray, when you apply on your body, you press its nozzle, the gas comes out. So, you also can understand this. What is the compressibility? Compressibility is the pressing the gas, passing the molecule, and that's taking the shape of the taking the shape of the container in which the substance is being kept. Is that clear? Now, fluidity. What is fluidity? The meaning of the fluidity here is to flow. So, can tell me this solid can flow? No. Liquid can flow? Yeah. And gas? Oh, yes. Liquid gas can also flow. So, now next is also there rigidity, highly, less, and not. What do you understand by the term rigidity? Rigidity means rigidness. How stronger, how rigid this is. Highly, the solid is rigid, and less the liquid is, and the gas is not rigid. Rigidity you can understand here. If you take a solid particle, solid object, and you try to push it the upper surface, the lower must rigid it. It's just not taking the shape of others. It's not changing its shape. This is called the rigidity. And diffusion. What is diffusion? Diffusion is the intermolecular movement. Intermolecular movement I just explained in the last lecture. What is called diffusions? So, we can speak here the simultaneously movement of the particles from the region of high concentration to the low concentration is said to be diffusion. And so, obviously, the movement of the particle is the concerning here, and the main concept, the diffusion is there. So, liquid cannot, the particle of the liquid cannot move easily, because they are lightly packed, and even they are in the attraction of the stronger force of the other molecules and the neighbor molecules. So, the particles of the solid cannot easily move. And the next, in liquid also is lessly attached the particles with each other. So, fast diffusions will take place here, but medium we can speak here, not the fast. Okay, but very fast is the diffusion in case of gas, right? That's why you get the fragrance very fastly when you apply the spray bottle, spray the fragrance on your body. Okay, in the bedroom, and the people who are sitting drying in the drying room, you can smell what you are applying on your body. This is the happening of the gaseous molecules movement from your one room to another room. This also happens in case of incense stick, when you burn incense stick at any point of the room, and this can be smelt from other room. Space between the particles closely packed. Spacing concept here. Obviously, solid does not have the space inside between the molecules of the solid. Even nothing could enter, nothing can be penetrated, nothing can go inside the solid. So, the space molecules is very stronger there. This also. So, closely packed, less closely packed, and least closely packed. And intermolecular force. The ninth point of difference is interparticle force. The force is actually keeping the particles together. Means this is the fourth fundamental forces I explained you in physics. Even in the world, there are four forces are here. The first force is the four forces are general W, G for gravitation force, E for electrostatic force, and N for strong nuclear force, and W is the weak nuclear force. So, interparticle force is stronger in solid, and in the gas it's highly, and in the gas it's negligible, and in the liquid is highly. So, on this basis of aspects and the characteristics of the matter in different states, solid, liquid and gas, we can understand the property of liquid here. Is that clear? So, before discussing the property of liquid, I just want to tell you how the question comes in examinations. So, in the examination the question comes, write the three characteristics and property of the liquids are here right now. So, first, what is the first property? Fixed shape and size. Second, volume, takes the volume container in which it is kept, less liquidity, fluidity and low density as compared to solid. And the first important property of the liquid is to be discussed here, that is property of liquid is melting point. Aspect of the liquid that we generally discuss with that is the melting point. So, what do you understand by the melting point, Sari? I am telling this, what is melting point? You will well understood here this melting point. Melting point. What do you understand by the term melting point? So, this is very simple here. You can understand this MP, melting point. If you will take here some liquid, means you will take a container and put the water into that container, and you will boil it for some times. Then what you will understand this, I think here right now you may see. Right now we will just take here the container, the beaker we have taken here, the tripod stand also. We kept the beaker on this here, and we will take the tripod spirit lamp, and water will take here. Where is water? This is water. Pour into that here. 50 ml approximately the water we have taken, right? And ignite this. Yes. We are just observing here what's going on this. The water is getting means we are giving the heat to the water, and after some times the water will obviously will try to turn. You might have seen this happening at your home. When you pour the water into the container and start heating it, after some times the water starts converting into the vapor. The vapor is the gaseous state of matter. We have the temperature measurement instrument here. We will measure the temperature. You may see what's going on here. The temperature is rising slowly here, centigrade 37, 30, furthermore also is there, okay, and 38, and once the situation will rise here, then the temperature of the water will reach to the 100 degrees Celsius, and we see that the water will start coming into the state of the vapor. This is called the boiling point. But what do you understand with the melting point? So, melting point is the ice state of water. You may see just here this. What do you understand? Melting point. The temperature, just you may write down here the definition. The temperature at which what is the solid start converting? Solid starts converting into liquid. This is called melting point. Example always to be given here at a 0 degrees Celsius. 0 degrees Celsius is the scale of measuring the temperature here right now. Ice starts or starts converting into vapor. Do you know the meaning of vapor? Vapor. This is called the 0 degree Celsius is the melting point of water. Is that clear? However, in case of water, we can understand here in just a simple it is water, liquid state. Water have the 3 phases. Okay, liquid and converts into vapor. Okay, and vapor liquid also when solid you will turn will give heat here like this is. We simply can understand here this solid when you will heat it, when you will heat the solid will convert heating it is. This heating is called melting. It is called melting. Melting turns the solid into liquid and boiling this is called boiling. Boiling turns the liquid into vapor and vapor converts into the solid. The process is called condensation. Condensation. So, what do you understand by the term condensation? Okay. So, here guys the temperature, this is all the concerning of the heat. We all just can take the shape of the different shape of the matter. This it happens due to heat. Is that clear? Heat, how can we measure the heat in the terms of with the heat can be measured in the terms of degree temperature, this is called. Okay. So, solid converts into liquid, liquid converts into vapor and vapor converts into again solids. Right now also solid liquid again can convert it into the solid. Okay. And solid can directly be converted into vapor and vapor directly can be converted into liquid. Is that clear? This can also happen here. So, that this concept is this is called the sublimation. This process is called sublimation. This is called sublimation. This is not called condensation. In case of this sublimation, this is sublimation. Okay. The conversion of solid into vapor, the conversion of solid into liquid, the conversion of vapor into solid, different states are here. So, different concernings to be discussed here, just like that melting point we will discuss here, melting point, melting and melting point, melting and melting point. Okay. And second is to be discussed here is what? Vaporization. Vaporization and vapor formation. Right. Now, next is the process of sublimation. The process of sublimation. Melting and melting point. What can you understand the term melting point? Melting point is very simply here. Melting point, when you take the water in the container or in a beaker and you give the heat to the substance, then what will happen here? Obviously, it will start boiling. It will start coming into the vapor. This process is called boiling. This is called boiling. So, it is called the boiling point, boiling and boiling point. Boiling and boiling point. Is that clear? So, first is melting point. Ice is to be converted into the water by giving heat. It is called the melting. The temperature at which the process is going on is said to be melting point. And vaporization, what is called the vaporization? Vaporization, the conversion of liquid into vapor is said to be vaporization, and the temperature at which the process takes place is said to be boiling point. So, you can understand here the example at 100 degrees Celsius temperature, 100 degrees Celsius temperature, water starts converting into what? Converting into vapor. Is that clear? This is called vaporization, and sublimation is to be discussed in the detailed manner. Understood your melting point, and the boiling and boiling point also is to be discussed here. So, one concept is to be very clearly is to be discussed here, vaporization and difference between boiling and vaporization. What is meant by vaporization and boiling? I am just explaining you vaporization and boiling. Yes, difference between boiling and vaporization. Boiling is called vaporization. Vaporization, and the second concerning is evaporation. Evaporation. What is called the boiling? Simply, if you will take water and water will reach at 100 degrees Celsius, then boiling will take place. But in the case of evaporations, you might have seen the clothes get dried when they are spread into the sunny light or in the outside door, they just get lost, they have water. This process is called evaporation. Even you also have seen the waters poured into the small pits outside the fields and outside your door, then you may see this water gets dried, no water more left here. This process is called evaporation. Also you would have seen the droplets and the vapor is getting rise up from the surface of the water, river and pond. You might have seen these all things here. This process is called evaporation. So what do you understand by the vaporization? Basic differences evaporation. So boiling takes place you may write down the difference, takes place at certain temperature. This is the basic difference here. Certain temperature, that is called what, please speak here, BB is called the boiling point. And what this evaporation? Evaporation takes place at any temperature. Right now, second, the boiling point, what is the throughout phenomenon? This we can speak here. If we'll see the temperature or the heat distributions throughout the medium, then it will be same in all points of the liquid. It means that what I am talking to, suppose that here you just taken a beaker, and in the beaker you have poured water and you are just heating it, and you are just heating it, you are heating this, then what will happen? In the water inside this, water is getting boiled inside this. Clear or not? So at this point here, I am just telling this, at this point, at this point, at this point, at this point, and at this point, point 1, point 2, point 3, point 4, and point 5. At different point, the temperature will same here. That means this point is getting boiled, this point is getting boiled, this point is getting boiled, this point is getting boiled. And this is taking place throughout this. So we can speak here, this takes place throughout the liquid, throughout the medium. This takes place throughout the medium. Is that clear? And the next is what here? This takes place on the surface. Is that clear? Furthermore, also the boiling is actually we can speak here happens in the case of the temperature rising. Right now, when you will start heating this, then the boiling will take place here. So what we can speak here, the movement of the molecules. Some more differences also can you give here. This movement of the molecules, all the molecules simultaneously. Also you can write down the molecules of the liquid throughout the mediums takes place here, movement, right? But in the case of the evaporation, only surface molecules try to move. Or the pressure differences also can also be predicted here, but only 2 to 3 difference you can write. The question comes only in the examination for the 2 marks worth value, right? So I have seen here the difference between the boiling and evaporation. So evaporation is the main concerning here. So our topic of discussing is evaporation. What do you understand by the term evaporation? So again we'll define here the term evaporation in the detail. Evaporation, evaporation, evaporation. What do you understand by the evaporation? As you have seen here, this evaporation, the surface phenomena, this is called. Okay, so we can hear the conversion of right now, conversion of surface, the conversion of what we can speak here, liquid, conversion of liquid into what here, vapor at any temperature, temperature is called, what is that here, is called evaporation. So this is surface phenomena, the main characteristic. This is surface phenomena, So I can just explain this concept here. Suppose that I am taking here the three container, okay, container 1, okay, and container 2 and container 3 container I have taken here. This is that clear? And I fill the liquid inside the container in equal height. We can understand this. In equal height, the liquid is filled inside that. This term is also as liquid paradox in case of pressure, but I am not talking about the pressure concept. Okay, in the three case, and all are giving here the we can say all we are giving the heat in equal amount to that. Okay, in equal amount, all that there is the like that. The thing I just want to ask here, 1, 2 and 3, in which apparatus the evaporation will take place highly? So obviously everybody can understand here. If we'll talk about the area, it means that this portion is, this is the area, surface area, and this is surface area also, and this is also the surface area. Okay, so you may see which is the greater surface area. So we can say surface area 3 is less than area 2 is less than area 1. You may understand here this. So the highest area is A1. So obviously why this happening? Because we'll see the surface profile of this. So molecules are closely attached here. This right now, this is the surface profile of the liquid here, and remaining surface liquids are here. This first layer 1 is called layer 1. So layer 1 liquid will first get dried up. They first will rise up, and later they will take the place of that. So what is the surface open to the atmosphere? How much the surface is open to the atmosphere? So bigger the surface opening to the atmosphere, bigger the rate of evaporation. So for first factor we can understand here. So what are the factors affecting the rate of evaporation? Factors affecting the rate of evaporation. So what is the factor here? First is surface area. And what is the second factor here? This, please tell me. The second factor, obviously, the what we can say evaporation, temperature. Temperature is also there. What the temperature here is there? Obviously, the evaporation takes place in the high temperature. It's like when very rapid movement of the molecules of liquid from the surface take place. The boiling point is to reach here. This, okay. So temperature. So how can we explain these all phenomena here? So after that, here wind blowing is also wind speed. I will explain you how this happen. Wind speed, and next nature of liquid also. Nature of liquid. The four are the factors affecting the rate of evaporation. Surface area, and I need to explain how this happens here. Since this evaporation is the surface phenomena, if the more the surface is there, large the surface here, so more surface molecules are open to the atmosphere. So more number of molecules of liquid will turns into the vapor, and hence the surface area will increase the rate of evaporation. So, we can speak of this in our home. We just dry our clothes by opening them, not to in folding manner. Right now, you might have seen this. We spread our clothes on the wire stretched. So, next is temperature. The temperature is actually, this is the temperature phenomena. Very less evaporation takes place in the cold countries and the less temperature. So, high the temperature, high, because it will increase the kinetic energy of the molecule. You just understand here, kinetic energy means when the heat is given, the temperature rise of the substance or a liquid, then liquid molecules come into motion faster than the previous. So, temperature will high the rate of evaporation. Wind blow, wind speed. It's simple phenomena we can understand here. Suppose that you may see this is the container containing this. Suppose that the liquid molecules are coming here, these liquid molecules are coming here. These are the liquid molecules. You may understand this, okay? These are the liquid molecules, okay? So, these liquid molecules are available here, right? And the wind is coming from here. So, wind will blow out all these molecules will be blown out. All these molecules will be blown out by the wind in this direction. Is that clear? And what here? The new molecules will come here, exactly. So, this space will be when made empty, then the remaining new molecules will come here, So, what that? Wind will is higher, the wind speed will higher, the rate of evaporation will higher. That is why we start running fan. We start the fan in the rainy season when there is no sunny or the light outside there, when the heat is less outside there, okay, then we set the running fan into the room to get the clothes dried. Is that clear? This is the example here of wind blowing speed. Also, we try to blow any hot food and any hot materials to make it rapidly cool. Okay. So, this is the illustration for the wind speed. So, increasing the wind speed, the rate of evaporation will also be increased. Nature of liquid, some liquid gets dried, some liquid gets evaporated fastly, some less. So, it depends on the nature of liquid. Everybody understand here this? So, factors affecting in the great detail, also you can appreciate the study metallurgs, right? You may say this is that is evaporation, the rate of effect of pressure, rate of evaporation, yeah, this is that here. Factor evaporation, a process in which liquid change into vapor without reaching the boiling point, that is called boiling point. Example is also given here. And factors affecting there is also humidity is another, but I did not explain you. Humidity means what? Presence of water droplet in the atmosphere. If already water droplet would be present, then how the dew water molecules will come into the space. So, this must be removed fastly. So, humidity is higher, less the rate of evaporation. Is that clear, guys? Hardly appreciate this question. This is very important according to point of examination of you right now. Okay, guys. Thank you very much. Have a nice day.